Matrix Game 2.0 is a real-time streaming open source interactive world model. This is specifically created for gaming. It's absolutely insane, and I want to give you a preview of how AI videos, AI games will look like in a couple of years from now. If you want to run this model, you can get it through Hugging Face, but you will need a very powerful NVIDIA GPU with at least 24 GB of memory. Of course, you could rent a GPU on the cloud and run it there, but you will also need 64 GB of RAM. So this model is quite heavy. If you want to run it, you need to have the compute. But it's important that this is open for everyone to use. So what these guys have done is three things. They have created a data production pipeline for Unreal Engine and GTA 5 environments. They trained on over 1,200 hours of interactive video data. They also have an action injection module that enables frame-level mouse and keyboard input as interactions. So instead of writing text, you can interact with the world using your mouse and keyboard. Also, they have a few-step distillation, which I don't know what it does, probably makes the model cheaper to use. So what this model can do is generate high-quality, minute-level videos across diverse scenes at ultra-fast speed of 25 FPS. Is this disappointing? Just a little bit, yes. This is not a model that you would use in your day-to-day life. This is on the frontier of world models, and specifically interactive world models, and specifically gaming world models. So let's see a small preview with multiple videos playing at once. Take a look at this. Oh yes, this is actually generated by this model. We can see multiple scenes from GTA. I have no idea what this game is. We also can see another game which is, where is it? Well, I don't know. Probably this game right down here. So this is the preview. Here we can see the model overview. So it has a 3D causal encoder that takes frames as input. It also has an image encoder. The encodings from these two encoders get into the Matrix Game Turbo Diffusion Transformer, which also takes as input the user's input through mouse and keyboard. And then we have a 3D causal decoder that generates the video. Hopefully in the future, these models will be able to generate unlimited hours of data, and they could use some kind of recurrent or sliding window logic so they can continue to generate high quality outputs, maybe with a bit of a bigger context. But at the core of this, we have a diffusion transformer, which is super important. Diffusion transformers are so powerful for any modality except text. But right now, they're coming to text as well. I think diffusion, and specifically diffusion transformers that have attention, or maybe some kind of attention, I think these will be the architecture that will get us to AGI. And this is how one block of this transformer looks like. First of all, it has the video tokens. Then we have the self-attention and the cross-attention that takes the input from the image encoder, and also a time step that passes through MLP. And then we've got the mouse action that gets attached with the image tokens, passes through an MLP. We see a mouse-driven self-attention and then a keyboard-driven cross-attention. So the keyboard input is passed through this phase over here, which is kind of interesting. I expected both of these to be in a single block here, concatenated with image tokens and the time steps. This is interesting. I didn't expect it. Maybe in the future they would have like a big cross-attention. Probably they did this to reduce the size of its attention layer, because it probably would be very, very big to inference and use. This looks smart actually, because they keep the attention size quite small, but they may lose some information. Who knows? So, performance comparison. Here you can see how the model compares against Oasis model, which I don't know what it is, but we can see here that the improvement is actually significant in most benchmarks, and this is on Minecraft scenes. Now, I want to see a little bit of it. One thing you will see quite fastly is that the resolution is not amazing. This model is open source, it's super costly, they probably don't have the resources to scale the analysis. Probably they could put like an NVIDIA super resolution and they could just upscale it, or real time. But here we look at the scene of a game. This is a variety of scenes that they want us to show us. So this is a snowy scene, looks nice, looks like a real world. We can see movement on trees, but the resolution is low. So hopefully in the future we will get higher resolution responses and results. Maybe they will do some kind of bottleneck layers so they can scale to bigger and bigger images, and probably they could get some funding to, really pump this up, because the higher quality images allow them to have better generation in total. So here we can see a house near a lake, the night sky. Guys, if they scale the resolution and the FPS, this could be absolutely insane. This is 12 seconds of video in every case. And let's see also this one. There are also some other examples that look exactly like games, which, it's going to be insane. So this is GTA scenes. So actually a person is using this. You can see the controls D as the input changes. These are also twice the length, 24 seconds. And yeah, this is truly a GTA car. Also the movement is a little bit fake. To be honest, this doesn't look like GTA. It's not very smooth, in all honesty. Let's see the next video. So this is the highway of GTA. It's able to understand all of the characteristics of the world quite correctly. Like, indeed, it's like GTA 5. Some hallucination here with the car. I really love how they are very honest with the clips. They know that their model is not the best model out there. But it's not the best world model, it has hallucinations, it does mistakes, but in total, this feels really realistic. You could feed a game into this model, fine-tune it, and get literally generated worlds live, which is insane. Incredible. For endless kind of games like parkours or maybe stories that are written on the fly, this could be amazing. So now we can also watch long video generation. This is 1 minute of video, and this is a work in the park. Really, you can really see the details. Even though the resolution is low, you can see the actual details. You can see that this world is realistic, but it just lacks the resolution. So probably just by scaling the resolution alone, using the same kind of data, they could get a very, very much better model. However, it's going to cost a lot more, probably. So yeah, we can see here that, yep, this is the world. It would be interesting to see if it has consistency across multiple times. Probably it does, but it can only handle like 1 minute of time steps. Maybe in this kind of case, maybe you need some kind of specific retrieval augmentation using a specific database. Maybe you actually use these models to create the 3D world as a game developer or as a movie person, and then this model, generates the world and you build the game on top of it. Maybe that's what it's going to be happening as an intermediate step, because you can get this and turn this into 3D using AI, and that would be powerful on its own. You could literally generate maps in a single day. So yeah, this is absolutely amazing. This is very, very nice to see. Give this a try, Google Matrix 2.0. I think this is super interesting. They also have shared the technical report. This is Skywork AI. Every guy here is pretty much Japanese or maybe Chinese. They are probably Chinese. And they also got this AI tool kit. Is that real? Maybe it is. So that's very, very interesting from them. This is absolutely amazing and lovely to see. Thank you so much for watching. I will see you in the next video.